Hey guys, it's Friday. I'm going to be traveling today to Hiroshima. You guys may know of that place because that is where the United States bombed Japan with the atomic bombs. We're going to be traveling around there to see what remains of that city after the United States bombed it. I'm going to have some pictures for you guys when I get back. So today's notes are on isosceles triangles. I've kind of lost track of what page you guys are on, so if you'll just make sure whatever worksheet that you did on the interior and exterior angles go in your book after the notes, and then whatever page we're on now is going to be for isosceles triangles. So remember, just listen to the notes first, and then you'll pause to write them down. So isosceles triangles are triangles with two sides of equal length. And so you guys probably already knew that. So in your triangles, you usually see these tick marks here to show that this side and this side are congruent. I want you guys to label your picture up top that the vertex angle is the one between the two sides that are congruent, and base angles are opposite of your congruent sides. Do you see how we have the arrow that points to the opposite angles? Those are called your base angles. So in isosceles triangles, you have two congruent sides and you have two base angles. So the one that is not your base angle is going to be your vertex, the one that's different. So for isosceles triangles, we have the theorem: if two sides are congruent, then the opposite angles are also congruent, or another way of saying that is the base angles are always congruent. So whatever side is opposite these two angles must be the same, and these two sides must be the same if we have an isosceles triangle. Okay, pause the video to write down your notes. Okay, we're going to do a couple examples here. In the first example, we have this mark X and X, tick mark, and we have X and 70. Where is the vertex angle? This would be the vertex angle, okay, up here, and these two would be called base angles. So since this is an isosceles triangle, what we know is that this angle and the other base angle must be equal. So what is X? It's just 70. Okay, remember to watch the examples first, and then I will give you a chance to copy them down. In our second example, we still have an isosceles triangle, but this time they did not use tick marks. This time they just wrote that the number 2 and the number 2. So that does tell us that this is an isosceles triangle. And base angles would be these two here, and this would be my vertex angle. So in this one, we're going to see that if these base angles must be congruent, what is X? Well, it must be 45 if these two are congruent. Very basic. Now we're going to step it up and make it a little bit more challenging. This time we have an isosceles triangle where these two sides are congruent. This is the vertex angle. And then up top here is where we have our two base angles. So since those two base angles must be congruent, because this is an isosceles triangle, this side and this angle must be set equal. So all we do is we set an equation. Set them equal. X plus 10 equals 2x minus 30. And then we can move the 30 from, okay, so Miss Chasen did this a little bit differently than I would. I would do Larry Snow method and move the 2 over, and then move the 10 over by subtracting it. The 2 over would be negative 2, and then solving it that way. Either way, you're going to get an answer of x equals 40. Okay, pause the video to write those two examples. And then we're going to have here a few you-tries. So I'm going to cover up the answers, and you can copy down the pictures, and I want you to determine what x is and to determine what x is. So try those problems. Pause the video now. Okay, hopefully you've had a chance to try the videos now. So let's uncover and see what you got. So you should have, for the first one, had x is equal to 15, and on the second one you should have gotten x is equal to 52. Okay, let's keep going in our notes. The opposite of that theorem is very, very similar. It just says if the base angles are congruent, then the sides must be congruent. So this time we know that these two angles are congruent, so that means we can say that this side is equal to this side. You're going to do the exact same thing, you're just going to set the sides equal to each other. If you're doing the exact same thing, you're just setting the sides equal to each other. So remember, watch the notes first, and you can pause and copy them in a second. So if I know these two base angles are congruent, then I know these two sides are congruent, so x is 15. If here we have a degree of 50 and a degree of 50, so these two sides must be equal, so we set the equation 2x equals 30. Divide both sides by 2, and what is x? 15. Okay, this one is slightly slanted, so it's hard to see, but we have base angles are here on the right side. We have 3x minus 13 and x plus 5. Then we're going to set those equations equal, because the sides must be congruent. If the base angles are congruent, it's isosceles. And you solve the equation, and we get x equals 9. You can pause the video here to write them down. Okay, we have a couple U-tries. I'm going to cover them up so you can try them on your own. And here we go. You can try those problems on your own. We have 3x and 27. Over here we have 50, 50, 3x plus 5, and x plus 45. Okay, you should have had a chance now to try those. Let's go over those answers. So you should have gotten x is equal to 9, and over here the x was equal to 20. Remember, listen to the notes first. We're going to be talking here about perpendicular bisector theorem. So, perpendicular bisector says that if you put a perpendicular bisector, we know that the word perpendicular means that it makes a right angle, right? So that's what this picture means here. A perpendicular bisector, let's talk about what a perpendicular bisector is. It's a segment that is perpendicular and passes through the midpoint. So the word bisector means it's cutting it in half. So this point is the midpoint of this segment. Okay? This point here is the midpoint, and it makes a right angle. So that's what a perpendicular bisector is. How this applies to us in triangles is we say that any point that I put on this perpendicular bisector, so this line here is the PB, the perpendicular bisector of this triangle. Any point that I put on here is equidistant from its endpoints of the segment. So what that means is that this is going to be the same as this. Or if I put a point up here, up top, that this length will be the same as this length. Okay? That's the perpendicular bisector theorem, which applies very closely with isosceles triangles, because now you can see if I connect this red, I've made an isosceles triangle because this has 3 marks and this has 3 marks. So we have an isosceles triangle here. What we can say then is that this is congruent to this because this was the midpoint, the perpendicular bisector. Let's try a couple examples because this is kind of hard to understand in words. Okay? Here are our first 2 examples. Please first listen. Let's say we have this picture, and it's labeled 2x and 26. Okay? Because this is here, and I have this right angle symbol and the tick marks, I know that this red segment here is the perpendicular bisector. That is the perpendicular bisector because it's midpoint, which is indicated by these 2 marks, and it makes a right angle. So, because this is the perpendicular bisector, I can then say that this side is equal to this side. So that's all the equation that you're going to set up. 2x is equal to 26. Divide both sides by 2 and get 13. In example 2, we have a very similar picture. This line here in the triangle is the perpendicular bisector because it makes the right angle, which is perpendicular, and it says that this side is congruent to this side, which means this is through the midpoint. So if this is the perpendicular bisector, and it is, then I know that these 2 sides are congruent, kind of like an isosceles triangle. You just set those 2 sides equal and solve. Okay, here are a couple U-try problems. And it looks like this one didn't get an answer, so first I'm going to cover it up to let you try it. So first I'm going to cover up the problem, copy these down, and you can give them a try. Okay, so I'll work this one out real quick since it did not have an answer. For this one, this is the perpendicular bisector. I know because it is through the midpoint since these 2 sides are the same. And it makes a right angle. So I can set 2x plus 5 equals to x plus 10. And if we do the Larry Snow method and we move the x over, we have 2x minus x and 10 minus 5. 2x minus x is going to be 1x. 10 minus 5 is just 5. And then your other answer over here was x is equal to 2. Okay, you guys are now going to work on a worksheet. Mrs. Smith, if you will pass that out, and then you guys will put that in your books, please. So guys, today was my last day that I will be away. Monday is going to be a teacher work day, indicating the end of the grading period. And then I will be back to school with you guys on Tuesday. See you then.